Hello everyone, welcome to Sir's classes. This is Tushar Shaw, and in this video we'll be continuing to solve the BHU PET 2020 questions that we were solving since the last 12 videos, I guess. Okay, so we did up till question number 12, and I'm explaining the whole part, the whole topic related to that question. In the specific video, so therefore it is requiring quite a lot of time, and thus only one question has been done per minute per video. So what you do is you will be requiring to watch all the videos so as to get the proper explanation of the detailed topic wise discussion of that particular question. Okay, so let us firstly look at the just change the pen. Okay, so basically, let us firstly discuss the question paper pattern of BHU PET. So it has BHU basically Banaras Hindu University. This PET examination is for MSc Chemistry admissions. Okay, admissions. It is conducted every year, and we are here this in this year we are solving the question of 2020, and like we were solving since the last many videos, and just we are continuing it this in this one. Okay, now in this set of paper we have all in a total 120 questions, among which all of them are MCQ type questions. Okay, MCQ, that is multiple choice questions are there, which would have one correct option in the four options that are given to you. A correct answer would be fetching you 2 marks, and an incorrect option being selected would be taking away half mark from you. Okay, half mark will be deducted. And for solving this 120 questions you will be provided with 2 hours, so like you have to do it in a hurry, otherwise you won't be able to complete the questions even in time. Okay, basically 120 question in 2 hours, it won't be eventually completed in 2 hours, but you have to do it fast enough so that at least you can get a good ranking or something. Okay, irrespective of that, let us look into the question that we have, and we'll let us solve it quickly, then we'll be moving on to the next video with the next question. Okay, so the question asks that, question number 13, it asks that how many molecules of periodic acid are used in oxidative cleavage of glucose to convert it into formic acid. Okay, so basically periodic glucose, as we all know, let me draw the structure of glucose for you. CH2OH, we have four chiral centers, H, H, OH, H, and OH, H, OH, OH. Okay, this is the structure of glucose, and per iodic acid we know it as HiO4, which is a very strong oxidizing agent. Very strong oxidizing agent. Oxidizing agent. Okay. Now, before learning about the glucose, let us firstly look at how oxidation takes place in alcohol, because maximum of the groups in the glucose are alcohols. One of them is an aldehyde. We'll be getting into that part later. So, firstly, if we take an alcohol, okay, this on first oxidation would be giving an aldehyde. Sorry, HCHO. This on second oxidation would be giving HCOH, which is an acid. So, alcohol to aldehyde, aldehyde to acid, and then if we like oxidize this part also with some amount of heat, this will be oxidized to carbon dioxide. Okay, carbon dioxide. So this is how oxidation takes place in various alcoholic groups. Now if you are giving a very strong oxidizing agent, this alcohol will be directly converted into acid, or if the oxidizing agent is like combusting one, then it will be converted directly to CO2. If it is a mild oxidizing agent, then it will be firstly oxidized to aldehyde, then it will be going on further step, taking the step ahead, it will be converted to acid. Okay, so basically this is the way how oxidation works. Now you are given periodic acid in the in glucose, and you are asked what are the number of formic acid that will be formed, or basically what are the number of molecules of periodic acid that will be required for the total oxidative cleavage. Okay, so you can see that two carbons which are attached and have simultaneous OH groups in the system, they are being oxidized by in the presence of HiO4. Okay, so let me just show you an example about how that works, and then we'll be correlating it with the hydrogen one. Okay, so let us take ethylene glycol. Okay, we have lone pairs of electrons over here. So HiO4, basically IO4 minus. So let me draw the IO4 minus. O, and here we have O minus. Okay, so this lone pair would be attacking over here. This bond will be opening up. We will be getting this kind of complex basically. So CH2 O H, we have plus over here. We have CH2 O H. We have I double bond. O minus, double bond O, double bond O, and double bond O. I'm sorry, here will be one OH. Okay, let us remove we have done the direct displacement. So this would be the complex that will be formed. Again, what would happen is this lone pair of electrons would be attacking again and releasing one more this double bond O. Okay, so the chelate that will be formed, basically a chelate will be formed, a ring compound, um, O O I, and we have OH, double bond O, and OH. Okay, now what would happen is this bond will be falling over here, this bond will be going over there, and this one will be going over here. Okay, so we will be getting CH2 double bond O and one CH2 double bond O plus HiO3. Okay, so this is the mechanism by which the oxidative the oxidation with respect to HiO4 is normally done in connected alcohol groups. Okay, so in this case you can see, let us draw the correlate with that, and let us draw the same for glucose. So let me just choose another color for that purpose. Okay, so for glucose, let me just draw the structure of the tempting structure of glucose. So CHO, CHOH, 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 CHOH. Okay, I'm sorry, yeah, CH2OH. Okay, so first of all, you can see that let us start from the beginning. So for breaking of this bond into formation of one CHO, that is the CH2, the CH2OH, this part would be forming the one molecule of CH2 formaldehyde. So here 1 mole of HiO4 would be converted to HiO3. Okay, again this bond will be broken by one HiO4. Again this bond will be broken by one HiO4. This bond will be broken one HiO4, and this one will be broken one HiO4. So total 5 molecules of HiO4 is used for breaking of all the CHOs, forming 5 5 HiO3 are formed as the byproduct of the catalyst. 5 CH2 double bond O, which is basically formaldehydes, are formed by the CHO by the alcohol groups, and one formic acid is formed because of the presence of because of the oxidation of aldehyde group. Okay, so one formic acid is formed. So basically, if you write the reaction in an overall manner, what you will be getting is, let us take again, we have CHO, CH2OH, we have OH, OH. Okay, in this case we will be requiring 5 HiO4 molecules of this one. We will be getting 1 HCOOH plus 5 HCHO plus 5 HiO3. So this is the overall reaction, which is basically the the exact thing that we need to figure out while if you want to solve the answer, find out the answer. Okay, so you can see that 5 HiO4, 5 periodic acid molecules are used, and therefore you will be in the option C. Here we have 5, so option C, 5 is the correct answer. Okay. Okay. Now, why it is not 3, 4, or 6? Because the number of bonds between the carbons are less. You can just correlate with the fact that there are 5 carbon-carbon bonds and therefore 5 HiO4 are required. So, for a species having 3 carbon-carbon bonds, for example, let us say arabinos, okay, D-arabinos. So for for yeah, for dearobinos, then we have some carbohydrate species which has 7 carbons in them. So seven carbons in them, 6 plus the carbon carbon bond will be remaining. So then in that case, we will be having 6 as the answer. Okay, so that this is the overall concept that we need to like learn before for solving this question. Okay, I hope you have learned a lot about carbohydrate oxidation of carbohydrates, and basically oxidation, this is like extensive oxidation directly breaking the bonds in between. Other than that, many other types of oxidation without breaking of bonds is also possible, but that is a topic for another video. Okay, so let us end this video here. I guess I hope you have learned how to solve how to solve this question number 13 of the BHU paper chemistry. So thank you guys for this video. I'll see you guys in the next one.